All right, today we're learning section 3.3, solving equations with variables on both sides. So we're still working with equations, we're still solving for the variable, except now we have variables on both sides of the equation, and we have to move it to one side of the equation. We're on page 131 in our textbooks. Okay, so in example 1, I have a variable on both sides of the equation. I have 7n and 10n. Now, while it doesn't matter which way you move the variable, I like to move the smaller variable to the other side, which means, which one is smaller, 7n or 10n? 7n. So how do I get rid of a positive 7n? I subtract 7n from both sides. And here's what that does. It helps me avoid having a negative number attached to my variable. If I move my smaller variable to the other side, then I'm not going to end up with a negative variable. Sometimes you can't help it, like if you have two negatives, but most of the time it works to do it that way. All right, so now I have a negative 5 left on this side equals 3n plus 13. And now I can just solve this like a regular two-step equation. What do I do next? I need to subtract 13 from both sides. I need to move everything that is not connected to my variable to the other side first. That cancels. All right, what's negative 5 minus 13? What's it going to be? Negative 18. Same sign, add and keep. Negative 18 equals 3n. Now I divide both sides by 3, and n equals negative 6. N equals negative 6. So based on what we just did with A, what about with B? What's the first thing I'm going to do here on B? Just tell me. What am I going to do?
10.
Hold on. No. Subtract 5A.
Oh, yeah.
Because I need to move I have to have my variables on the same side of the equation. So I'm going to move my smaller variable, subtract 5A from both sides. And I get 10 equals 10a plus 5. I need to now subtract 5 from both sides of the equation. So 5 equals 10a. Now don't get tripped up by this, all right? What do I need to divide both sides by? 10. So now look. 5 divided by 10. What's 5 divided by 10? No, it is 0.5 or 1/2. 5/10 reduces 5/10 reduces to 1/2. It is not 10 over 5. 10 over 5 would be 2. It's 5 over 10, which reduces to 1/2. So you might have some that are fractions for your answers. That's okay. It's not a big deal. All right, so, and I don't really care whether or not you write it as a fraction or a decimal. Now, I will say a lot of times it's easier to write it as a decimal because it's easier to go back and check. All right, I want you to do C, let's do C together. All right, now on C, I have negative 8b and 4b. Okay, so which one is the smallest?
Oh.
No. Which one's the smallest? Negative 8b, right? That's way smaller. It's in the negative. Okay, so I'm still dealing with the number that's the smallest. Okay, and here it's going to be negative 8b. So I'm going to add 8b to both sides. I'd much rather deal with a positive 12b than a negative 12b. Now, if you were to go the other way and subtract 4b from both sides, you still end up with the right answer. You just have to deal with negatives. So now you have 12 equals 12b minus 24. All right, two-step equation. What do you do next?
Add 24.
Add 24 to both sides. $36 equals 12b, and divide both sides by 3. 12. I was thinking the answer. Divide both sides by 12. And b equals 3. All right. So now I want you to do your turn, or the checkpoint. I want you to go ahead and do the checkpoint on, let's just do all three. We'll just take a couple of minutes to do all three of these. Okay, so this is the answer to A. We've got n equals 4. On B, subtract 8y from both sides. 4 equals 3y minus 17. Add 17 to both sides. 21 equals 3y. Divide both sides by 3. And y equals 7. All right, so again, I'm choosing the side that has the smaller value for the variable, so I'm going to subtract m. Now, if I'm subtracting m, what do I know is understood in front of the m? It's an understood 1. So if I subtract an m from 9m, what do I get? 8m. Negative 1 equals 8m plus 15. Subtract 15 from both sides. What's negative 1 minus 15?
Negative 16.
So negative 16 equals, same sign, add and keep. 8m. Divide both sides by 8. And m equals negative 2. All right, anybody get all three? Did you get all three? Okay, very good. Anybody just miss one? Miss one? All right, very good. Any questions? Any questions on one that you missed, you don't understand? Okay, now, in example 2, I'm writing and solving an equation. The word problem is on the top of page 131. It says the Spanish club is going to a Mexican restaurant in a nearby city. Well, everyone who goes has to pay $60 for the bus, total. Well, their lunch costs $5 each. So what it's asking us is, how many students have to go in order for them to only have to pay $10 each? Okay, well, the first thing you need to figure out is, what are you solving for? What are you solving for? It says, how many students must sign up? So we're solving for, we don't know how many students have to go to get the price down. Does that make sense? Okay, we should be looking on page 131. All right, so S is going to be my variable. S for students, does that make sense? My goal is that it's $10 per student. So here's the thought process that I want you to go through. Okay, why don't you just make up a number? Let's say 8 students went, and it was $10 for each student. Well, how much would it be total? Well, what did you just do? Did you add? Did you subtract? You multiplied. So that's what you're doing to your variable. You're multiplying 10 times you don't know how many students. Equals $5 times, do you know how many students? No. Plus a $60 bus fee. And now you're ready to solve the equation. So you subtract $60 from, or 60, I'm sorry, you don't subtract 60 first. You need to subtract 5s from both sides and get 5s equals 60, and then divide both sides by 5. So how many students need to go? 12 students. If any less than 12 students go, it's going to cost them more than $10 a piece, because they're going to have to each pay more per person for the bus. Okay? If more than 12 students go, then they pay less than $10 each, because they pay less money per student on the bus. All right, now, example 1, guys. Example 1 is the most important part of this lesson. Examples 3 and 4, these are like the exception to the rule, okay? Now, in example 3, we're going to have some equations that don't exactly fit the mold, and you'll see what I'm talking about in just a second. All right, we have to do what? What do we call this? It starts with a D. Distributive property. We have to do distributive property to get 10x plus 5 equals 10x. All right, well, here's the problem. They're the same. So what's going to happen when I subtract one from the other? Oh, you're going to have 0x, and that's impossible. So 5 equals 0x. All right, your answer is not possible. You can't have 0x. So anytime you're solving a problem and you end up with 0x, your answer is not possible. All right, so I want you to do B on your own, just like we just did A. All right, so 3 times 5x is minus 15 equals 15x. All right, same problem. As soon as I subtract 15x, I get 0x. Negative 15 equals 0x. NP, not possible. Solution is not possible. There is no solution. Now in example 4, okay, example 4 is a little bit different. Again, these are the exceptions. So 99% of them are going to look like example 1. And then you have the other 1%. Sometimes this happens. 6x plus 2 equals, what's 2 times 3x? 6x plus 2. Well, that's the same exact expression on both sides of the equation. Do you see that? So it doesn't matter what number I plug in. There's going to be more than one solution. Okay, let's test the number 3. What's 6 times 3?
18x.
What's 18 plus 2?
20.
What's 6 times 3?
18.
What's 18 plus 2? 20. Okay, what about 5? What's 6 times 5?
30.
What's 30 plus 2?
32.
And guess what? It's going to be the same thing for the other side. So any number can be a solution. Anytime you have the same expression on both sides of the equation, your solution is going to be all real numbers. So all you have to do is write the expressions so that it shows both sides are the same and box in all real numbers. All right, so 4x plus 6 equals 4x plus 6. So again, same expression on both sides of the equation. My solution, all real numbers. Okay, now there is an example 5 in this lesson. We're not going to do it, which is why I've changed your homework to 4 through 26 even. So if you understand that, then that's everything you need to know for 3.3.